It's very far above my expectation.
Show the customers what we can do with our product.
Matt Noseworthy is here from the University of Manitoba, and Cigi over the years has been really good in supporting Canadian organizations in providing facilities and or equipment for research purposes. So Matt is here working on a project with pulse flowers. Today we're using the hammer mill, and what Matt has done is he has extruded a number of pulse flowers using our twin screw extruder downstairs, and they're looking at the effects of heat and the nitration of protein through processing. So he took the extrudate from the extruder, and he is milling it down into a flower form, and they will use it in animal trials, feed trials at the University of Manitoba.
My name's Matthew Noseworthy, and I'm a postdoctoral fellow at the University of Manitoba, working in the lab of Dr. James House, and I've been investigating protein quality, specifically with pulses. What I've been doing here is taking samples of 10 different pulse classes from lentils and peas and beans and chickpeas, and I've been putting them through a process called extrusion, which is a heat process that's potentially going to affect the protein quality that's present in these samples. And so overall, the arching project is looking at the difference between various processing methods, between extrusion, a baking process, and much like what you do back in your home kitchen, and looking at the overall effect of both protein content and the quality of the protein that's present in these samples. One of the reasons why I'm down at Cigi is because they have the specialized equipment as well as experience of other individuals that have gone through various processes such as extrusion or using the hammer mill. And so we've developed a good working relationship over the years with Cigi. This is a multi-year process. And so we're getting close to beginning the direct experimentation now, and we're hoping to have all the data generated by the end of the year. With protein quality, it's basically divided into two different things. How nutritious is a particular product, but also how available is that nutrition to the individual. And through heating, through baking, this can have an effect on how easy it is for these nutrients to get into the body. And so by going through these experimentations and doing these analyses, we're able to determine the most suitable product for any of these pulse classes. What's good for a bean is not going to be what's the best for a lentil or for a pea. So we're able to compare and give guidance to individuals that are either trying to generate a product or look towards finding the best possible scenario for some of their initial products. If you're going to produce a cracker, is it going to be better for you to produce it by extrusion, or is it going to be better to have some sort of baking process? What's the difference in the protein quality? What's the difference in the nutrient capacity for the individuals consuming it? And how does that compare to somebody taking a bag of beans and putting it on the stove when they get home? So that's why we chose those three different comparison methods, either extrusion, baking, or home cooking.
We have done quite a bit of work with the University of Manitoba, and the university is quite good at bringing staff here, and we're able to train them on the equipment, and they can use the equipment on their own with some supervision. We are able to funnel some of the requests that we get about pulse quality and effects of processing on pulse quality to the university. So we're able to make a connection between a customer potentially and the University of Manitoba and Canadian pulses.